Streacom's DB4 was introduced in 2016 and quickly earned a lot of attention due to its extremely unique and bold design. It is made up of a cubic skeleton with a centered motherboard tray and 4 hefty extruded aluminum heatsink panels. All of the input and output connections are hidden at the bottom of the case, so that when you are looking at it from above, all you see is the monolithic metallic cube. If you didn't already know, you probably wouldn't guess that there is a complete desktop PC inside it, especially when it is passively cooled and fully silent. The case comes with 4 6mm heat pipes to transfer heat from the CPU to one of the 4 heatsink panels. It is rated to cool 65 watts with the stock heat pipe system. Streacom offers an LH6 CPU cooling expansion kit that increases the CPU cooling rating up to 105 watts by utilizing a second heatsink panel. They also offer a GPU cooling kit that is rated to cool 65 watts from a graphics card utilizing a third heatsink panel. An optical disk drive is available for those who still want to be able to use optical disks. Without the additional cooling kits, the build process is quite simple and straightforward. However, when adding the LH6 and GPU cooling kits, the build process can become more complex and difficult. Streacom provides both thermal pads and thermal paste. However, you will get better heat transfer by using thermal paste on all surfaces. If you do decide to use thermal paste, you will need quite a lot of it. One of the difficulties with this case when using paste is getting adequate pressure between the heatsink mount and the heatsink panel. I found a way to do this by using a few of the extra screws that Streacom provides between the universal brackets and the heatsink mounts. The DB4 measures about 10.3 inches wide and 10.7 inches high. It weighs about 16.6 pounds when empty. The case is only compatible with many ITX motherboards, several 3.5-inch or 2.5-inch drives, Streacom's ZF240 power supply, or a modular power supply with external AC to DC adapter, and graphics cards that are up to 7.8 inches long. It comes in either a silver, black, or in-between titanium color. The PC I will build here includes the Intel i7-11700 CPU, an ASRock Z590M ITX motherboard, 64 GB of Mushkin Redline 3200 MHz memory, a Samsung 980 Pro 1TB NVMe drive, an Nvidia Quadro P2200, Streacom's ZF240 power supply, and Streacom's LH6 and GPU cooling kits. The PC will be used as an architect's personal AutoCAD and Photoshop workstation. largest difficulties when assembling this case are getting the LH6 cooling kit properly installed and aligned with the stock cooling kit before installation of the heatsink panels, and creating enough pressure between the heatsink mounts and the heatsink panels. When you use the included thermal pads, the thickness of the pads helps to create adequate pressure. But when you use thermal paste instead, you need some additional pressure. The universal brackets alone don't seem to do it for me, so I've resorted to inserting some of the extra screws provided with the case between the heatsink mounts and the brackets to create a little bit of extra pressure. Perhaps a thermal pad here instead would work well too. To test the thermals of this system, I used Prime 95 to stress the CPU, Fanless to stress the GPU, and Hardware Info 64 to track temperature and power data. The 8-core Intel i7 can draw huge amounts of power, far above 100 watts, so I knew ahead of time that I would want to apply a power limit to the CPU. I tested the CPU at 5 power limits, from 35 to 95 watts, so that I could create a trend line to estimate the DB4's maximum CPU power dissipation with the LH6 cooling kit in place. Unfortunately, the Quadro GPU does not allow modification of the power limit, so it was tested at its stock power limit only. Each stress test was run for half an hour to get reasonably close to heat saturation without spending too much time. Here's the data for the CPU. From prior experience, I know that the trend line should be linear, but the data did not appear linear here. So, I forced a linear trend line with the y-axis intersection at 32.5 degrees, which is a normal intersection point for these kinds of trend lines. It is not the best fit, but I am satisfied with the result. If you use the trend line formula to calculate what power limit would be expected to cause thermal throttling at 100 degrees, you get 99 watts, which is just a bit below the 105 watts that Streacom recommends with the LH6 kit. To be fair, I only used 2 of the 3 heat pipes and 1 of the 2 heatsink mounts from the LH6 kit, so it might do a little better with all 3 heat pipes and 2 mounts. I left the long-term power limit at 95 watts, so I wouldn't expect any thermal throttling of this system at normal room temperature. These results were obtained with a 25-degree ambient temperature. Now moving on to the GPU. After half an hour of Fanless, the GPU ended up at about 79 degrees. It was still slowly increasing at that point, but I am confident that it would level out in the low 80s if left to run indefinitely. The P2200 ran with an average power use of 62 watts. Nvidia does not list a maximum temperature for this GPU, but there was no thermal throttling of any kind during this test, and these temperatures are safe for most GPUs. 62 watts is just below Streacom's 65 watt rating for the GPU cooling kit, but based on this test, I think there is a little room to go higher, up to 75 watts potentially. With a 75 or 100 watt Nvidia GeForce card, you could use graphics card software to reduce the power limit to Streacom's recommended 65 watts to improve thermals. Next, I tested the performance of this system using Passmark Performance Test. The Intel Rocket Lake i7 received a score of 4.5 out of 5 stars, and the Nvidia Quadro received 3.5 for 3D graphics and 5 for 2D graphics. Both the memory and the M.2 SSD received 5 stars. The system received 5 stars overall, and ranked within the top 2% of all results. It is actually the highest overall Passmark Performance Test score that I have ever received. When you look at this case and consider its passive cooling potential, you might think that it works well only for a media PC that doesn't require much power. Well, that is a good use for it, but it can also be used for so much more. A silent server, for example, or even, as we saw here, a workstation. What it would not be great for is a high-end gaming PC due to the power restrictions on the GPU. With up to 100 watts from the CPU and 75 watts from the GPU, though, there is a lot of potential. To get photos and test results of every one of my PC builds, check out my Patreon page. Like the video and subscribe for more fanless PC content, and visit fullysilentpcs.com if you are interested in purchasing your own pre-built fanless PC.